Welcome to GCSE Maths. Today we're diving into the exciting world of 3D Pythagoras, and we'll even use nets to help visualize the shapes. Pythagoras' theorem isn't just for flat shapes, it's essential for understanding distances in three-dimensional objects. Let's explore how it works. First, a quick recap of the 2D Pythagorean theorem. A squared plus b squared equals c squared, where c is always the hypotenuse of a right-angled triangle. In 3D, we're looking for diagonals within solid shapes, which often means applying Pythagoras more than once. It's a step up, but totally manageable. Nets are fantastic tools for visualizing 3D shapes in 2D. They help us unfold the shape and see all its faces and edges clearly. For example, a cuboids net shows all 6 rectangular faces laid out flat, making it easier to pinpoint specific lengths and diagonals. By looking at a net, you can easily identify where right-angled triangles are, quote, hidden within the 3D structure, which is crucial for applying Pythagoras. Let's work through an example with a cuboid to see 3D Pythagoras in action. First, we need to draw the right-angled triangle on the base of the cuboid. This will give us the length of the base diagonal. In this problem, you have the cuboid, A, B, C, D, E, F, G, H. We have to calculate the length of AG. The first step is to find the hypotenuse of the rectangle along the base of the shape. You will use a squared plus b squared equals c squared to find the diagonal AC, which is about 9.43. Remember not to round until the very end. Now you will then use a squared plus b squared equals c squared to find the final diagonal, AG. The hypotenuse of your last triangle is now one of the shorter sides in your new right triangle. You will now calculate the 9.43 squared plus 4 squared and take the square root of your answer. Your final answer is 10.2 to the first decimal place. By carefully identifying these triangles, you can use Pythagoras to solve for unknown lengths, such as the pyramid's height or the slant height of a face. If you are given an angle, you will have to use SOHCAHTOA to find the missing angle or side. In this example, we have a triangular prism that we have to find the size of the angle AFC. In this problem, we have redrawn 3 right triangles below to be able to see what is happening clearly. The first step is find the length of FC. Since we are using an angle to find the length of a side, we will use SOHCAHTOA. Since we are looking for the opposite side and we have the adjacent side, then we will use the tangent. FC is about 4.04 centimeters. Remember, do not round until the very end. Now we will find the diagonal AC. We will use Pythagoras because we have 2 sides, and we are looking for the hypotenuse. The diagonal of the base rectangle is about 12.02. Finally, we are able to answer the question, which is calculating the size of the angle AFC. Since we are looking for an angle, we use SOHCAHTOA. Again, we are using tangent because we have an opposite and adjacent side. Remember to type Shift-tan in your calculator to find the angle. The answer is 71.7 to the first decimal place. Here are some essential tips to master 3D Pythagoras problems. Remember, the key is to constantly look for those hidden right-angled triangles within the 3D shape, even if they aren't immediately obvious. Don't get overwhelmed. Break down complex 3D problems into simpler 2D Pythagorean steps. Solve for one diagonal, then use that to find the next. If you are in need of help, please contact us at www.thompsoneducate.com.